Topic 2, rational exponents and radical expressions. This topic only has one objective, but this objective is a little bit involved, and so as I talk through this, I'm going to ask you to pause the video to try the specific skill that I'm working on, just so that you can ensure that you're tracking with what I'm talking about, all right? So again, this objective states that I can simplify and convert radical expressions and rational exponents. So mainly simplifying radical expressions and then converting between radical expressions and rational exponents. All right, so to begin, we're going to go through some notes here. Sometimes fractional exponents, so powers that are written in fraction form, are used to represent power of numbers or variables. And the numerator of the fraction, I switched this, so the numerator of the fraction, I'm going to call it p, because p represents power, represents the power. The denominator, and I've switched this to r, represents the root. I tried to make it a little easier. P represents power, r represents root. The exponent in the denominator must always be positive, all right? Just keep that in mind. But here's a formula, and this is part of objective 1, convert radical expressions and rational exponents, all right? This format is the rational exponent, all right? So please write that down. You need to know that. I know that that's the rational exponent because exponent means power. This is the power, and rational means fraction. All right, so the power is a fraction, so it's a rational exponent. And here, this should look familiar because we've worked with this before. This is just the radical expression, and I know that to be the radical expression because the square root, another way to say square root, that square root sign is radical. So that's the radical expression. And in mathematics, there's a relationship between these two things. They technically do the same thing to the number a that exists underneath both the rational exponent and the radical expression. They're just written in different formats and used to do different things. And we'll get more into that later in this module. So some examples, and this is the first part. I'm going to convert radical expressions and rational exponents, all right? And this you'll practice in a little bit as well. I'm going to do examples A and B, and I'm going to ask you to do, well, no, they're already done for you. I'm going to do that down there. So just to talk through it, again, first is listed rational exponent. It can be converted to a radical expression, all right? And what they did here, x to the 1/2, all right? 1 being the p, 2 being the r, all right? The way I think about this is power always goes to the top, always, 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 and root always goes to the bottom. Think of roots of the tree. They always go to the bottom, all right? They grow into the ground. And so if I'm switching to radical form, the root that displays this square root is here, all right? It's 2. And then the power is 1. So the power always stays with the variable. It always goes above the variable, or above my a term, and the root always stays with the radical, all right? The way they wrote this, and this is a special case because if it is a square root, you don't have to put 2 right here. This sign, the radical, just the basic radical, means square root. So you don't have to put 2. And they didn't include the power of 1 because when it is the power of 1, you don't have to write that either, all right? So let's take you through the next one, right? 9 to the 1/2. I'm going to rewrite it here. Again, powers are above, so 1 is the power. Roots are below. 2 is the root, all right? So I'm going to write the square root, and again, I'll show you what I'm doing. This is the square root, so the root goes to the radical, stays with the radical, and the power stays with the variable. Except for it wasn't x, it's 9. All right? So, again, this thing you don't have to write because it's the square root and the power is 1. You just write the square root of 9, and the square root of 9 is 3. So if you recognize a relationship, any number raised to the 1/2 is the same thing as taking the square root of that number. And since 9 is a perfect square, 9 to the 1/2 is 3. The square root of 9 is 3. It's the same thing. That's the relationship. They do the same thing to that a value. They're just written differently. And then finally, part C, And this will be a good example because it shows you a little bit more of the thought process. I'm going to rewrite x to the 2/3. And I'm going to write, again, 2 is my p, or the power, above, right here. And 3 is my r, or my root, all right, below. And that's going to turn into, if I want to write it into radical form, my root, the r, goes with the radical, right there, all right? And the power stays with the variable, so it is x squared. So please recognize that relationship. The power always stays with the radical, and then in rational form it goes above the root, and the root always stays with the radical right here. Sorry, the power stays with the variable, the root stays with the radical. All right? So let's practice this a little bit more. So I'm going to do A, and I'm going to ask you to do B, just to check your understanding. So again, if I was going to look at A, I would first identify the power and the root. I'm going to rewrite this a little bit bigger. X to the 2/5. The power is 2. I know that because the power goes above. The root is 5. I know that because the root goes below. So if I'm going to switch this, and again the directions say write the expression in radical form. So it is in rational form, I need to write it in radical form. I know radicals have this symbol. And again, the root, the r, which is 5, goes with the radical. All right? It represents the root. So this is technically the 5th root. The 5th root because it's below and it's a number 5. And then the variable, x, goes underneath, and then the power stays with the variable. So it's x squared. All right? So go ahead and pause the video and try example B on your own. At this point, you should have paused it. So I'm going to show you how I would go through this process. I'm going to write it a little bigger. If you want to identify the P and the R, please do so. So the power is 7, the root is 4. So if I want to switch it to radical form, I know that the root goes with the radicals because it tells me the number of root. And so this is the 4th root. And then it's going to be a to the power of 7. All right? So please check your work with mine. If you didn't get that for your example, please raise your hand and I'll come talk to you about it. Moving on now, write the expression in exponential form. So going the other way, all right? So I know this to be, it's in radical form. If you look at example C, I know it's in radical form because I see a root sign, and it's telling me to switch it to exponential form. So my answer here should look something with a variable raised to a rational power. So I'm going to rewrite this a little bit bigger. Z squared. So it's in radical form. I need to switch it to rational form. So for rational form, I'm going to still include the variable, z, and then I'm going to identify my root, and I know my root to be the number paired with the radical, and I know my power to be the one that exists above the variable. And that looks pretty similar. Again, root goes with the radical because this is the cubed root, or the 3rd root, and then the power stays with the variable. So to write that, though, in rational form, the power goes above. The power is the numerator, so it's 2, and then the root, or r, goes below. So it's z to the 2/3 is my final answer. All right. So for this one, I want you to try, but I'm going to change, because we're not going to talk about that for the most part. Switch this. This is your new radical. Instead of c to the -5th, I just want it to be c to the 5th. All right. So go ahead and pause the video and try this radical. The cube root of c to the 5th. Switch it to rational form. All right, at this point, you should have paused the video. I'm going to switch it to rational form. I can identify my r and my p. Again, the root goes below, and this is my variable stays the same. The root goes below, so 3, it's the cube root or the 3rd root, goes below, the power goes above. C to the 5/3. Again, it's just another way to work with numbers, but the form stays the same. But at times it's easier to simplify things that are written in rational form, and at times it's easier to simplify things that are written in radical form. But hopefully that's what you got written in blue. If you didn't, please raise your hand and we can talk about it. Now, we're going to practice another skill that is necessary for this module, especially for this topic. This is review though, so I'm going to only show you briefly how to do it, then I'm going to ask you to do the next 3 on your own, okay? This is going to be breaking down radicals. And again, we're going to be working with different types of roots. So in this, if you notice, this is the square root. So when we're working with the square root, we just have to find a pair or 2 of the like terms to come out of the radical. In future examples, it will be working with different numbered roots, and so we have to look for different amounts of the same number to come out of the radical. But I'll do the square root of 18, and then I'm going to ask you to do the other 3. So again, to break these down, this is review. This is from Module 2 as well. I have to look for pairs because it is the square root. Whatever number is here is the number I need to look for pairs or for the same kind to come out of the radical. All right, so I'm going to break this down to 2 and 9, just factors of 18. 18 divided by 2 is 9. 2 is a prime number, so that's good. And then 9 breaks down to 3 and 3. So since this is the square root, I'm looking for pairs or 2 numbers that are the same. I have a pair of 3's. So my final answer, the 3 comes out, and the 2 is left inside, because the 2 did not have another 2 to take it out with it, all right? So it is 3 radical 2 for my final answer. Go ahead and pause the video and try the next 3 on your own. At this point, you should have paused your video. Please check your work with mine for the square root of 48 and the square root of 8. Here are my final answers. This is the final answer I got for the square root of 8. Again, I found a pair of 2's, so the 2's came out, and a 2 didn't have a pair, so it had to stay in the radical. So 2 radical 2. Down here, for square root of 48, it's a little bit different. If you notice, I had 2 pairs of 2. So each pair of 2 came out as the number 2, and when 2 things come out together, they multiply on each other. So 2 times 2 is 4, and the number that was stuck inside still that didn't have a partner was 3, so 4 radical 3. And I want to show you that thought process here. So hopefully your work looks similar to mine for the square root of 32. I get, let's say, 4 and 8, because 32 divided by 4 is 8. 4 breaks down to 2 and 2. 8 breaks down to 4 and 2. And 4 breaks down to 2 and 2. So similar situation. I have 2 pairs. Again, I have a pair of 2's there and a pair of 2's there. This comes out as a 2, just 1 2, because again I'm looking for pairs because it's the square root. And this comes out as 1 2. I have to, when they come out, numbers come out into the same location, either out or inside, you have to multiply them. If there was 2 numbers on the inside of the radical, I have to multiply them again. What's left in the radical is this 2 because it didn't have a partner. And then finally 2 times 2 is 4, so 4 radical 2. And I'm done. So again, if your work didn't match mine, if your answers didn't match mine, please raise your hand and I will come check them.